And we're going to have an introduction to functions today. This is section 2.1. We are now in the second unit. Before you do this unit, I'm suggesting that you take your test and review for that test. Okay, let's get started. I have some vocabulary for you. We're on your notes. If you remember, I had you keep your notes out. Some of you might have put them in. And that's the second page of your note sheets. It's your second page of your note sheets. You're going to fill in the blanks. I will be giving you some vocabulary. Perfect. Right there. The first one is input. Make sure you follow along. You know where we are right now, right? We have input. Okay. Input is the values you put into a function. I hope that seems logical. Input is something you put in. You put into a function. Another word for it is called domain. There are blanks that I've left for you. I think there's 2 blanks on that one. The values you do what? Put into a function, and that's that's the things you're gonna fill in the blank there. Put into. It's also called the domain. That's the second word. I capitalized it. You don't really have to. You could. All right, so input's the first word, and you guys have it on your paper. What's the second word? Output. And if input is something you put into a function, what do you think that output is? Things are taken out. Something you get out of a function that comes out. You might not know the word for that, but you might. It's the values that come out of a function. It's also called the range. I think you have to fill in come out and range. The next vocabulary word is relation. Okay? It seems like in this world, at the age you are, people want to talk about relationships all the time. This is not that. We're not going there, so you don't have to worry about it.
You already went there, so.
So we got a relation is simple. It's a set of ordered pairs, which means something like 2, 4, or 3, 2. It's a set of them. Set of ordered pairs.
I wish you'd given us a little more line.
Sorry, I'll consider that next time. Thank you for letting me know. Last one. This is the one that you really need to pay attention to today. The rest of them are important. The last one is function. A function is a rule that establishes a relationship between a set of ordered pairs. And if you need a highlighter, I would highlight the very last sentence of that. You're going to use it over and over and over. For each input, there is exactly one output. Each input, there is exactly one output, and I want to reiterate that goes forward, but it does not go backwards. You cannot read that for every output there is exactly one input. It doesn't work. It only works forward and not backward. For every input there is exactly one output. I'm going to give you an example, okay? And it's our birthdays, okay? The input is the person. If I took a person and I wrote, let's just do a person, letter A, and they were born on the 400th day, no, there's no 400th day, 216th day of the year, okay? And I have another person, and they were born. Can they be born on the 216th day of the year?
Yes.
Yes, that's logical. We can be born on, all right?
No, that's illogical.
All right, so they could be born on the same day. That's okay, right? But can you, person number A, be born on the 216th day and the 45th day?
Yes. Yes.
I'm talking about the birth.
Yes.
I'm talking about the birth your mother gave you, not the day you want to be baptized or all those things that we talk about. You're being reborn. I'm talking about the day your mother gave birth to you. This sentence cannot be read backwards. It's got to be forwards. For each input, there's exactly one output. This person A, cannot have 2 different birthdays. So this would not be a function. But
Unless you're Muslim.
We can have 2 different persons like this. This would be a function. And I could also have 2 people can have the same birthday. All right, let's look at this real quick. I want to know if these are functions. I've actually put the rule that you highlighted, so it's up on the screen. For each input, there's exactly one output. This first one, this is called a relation right here. This is an ordered pair. This is the ordered pair, 0, 5. The next ordered pair is 1, 3. Another ordered pair, 1, 8, and 3 comma 10. Is this a function? Yes or no? Does each of those inputs have exactly one output?
Yeah.
I heard some people say yes.
No.
I'm hearing somebody say no. Can somebody the no, will you tell me why you think that?
Because there's not one output.
There's one of them is there one of them that has multiple outputs?
Yeah, when you say output, because
Change
it's
your
like
answer.
one number, because it's 0 and then it goes to 5.
0 goes to 5, but 1 goes to 3. What else does 1 go to?
8, so that's not.
So this does 1. This would be like person number 0 having a birthday on the 5th day. Person number 1 has a birthday on 2 different days, and this is impossible. This is not a function. Okay? This is not a
So
function.
I got it right?
So you got it right. Congratulations.
Wow.
All right. All right, I got a no down there at the bottom of the screen.
I was just gonna put next over at your next.
Yeah, you can. You can do that also. The next one. Is this a function?
No.
I heard no.
Because there's two
Yes.
2s.
I heard there's 2 2s. I
Oh,
heard
this-
yes, it's a function. Is this okay or is this wrong? The
okay.
2 2s is the one that's in question
It's
here.
okay. It's okay.
It's okay, how come?
Yes, because the 2 2s are in the output range.
That's correct. Person number 5 can have a birthday on number 2, and person number 4 can also have a birthday on day number 2. That's okay. This is okay. So this is a function.
Same person.
All right. So is this a function? Yes or no?
No.
And the problem is the 2s again. Correct?
Yes.
And this is the people, and this person would have 2 different birthdays, and that would be a problem, correct? Okay. That's a no. The only one that was a function was the one in the middle. All right, we're going to do numbers 1 through 4, 17, 19, and 20. I'm going to bring them up here
And what? Review?
on your, not your review. That's good. That's a good question. On section 2.1. Section 2.1.
What are all the lines?
That's a good question. I'm going to go over those. That's why I'm going to bring it on up here.
Wait, 1, 4, 17, 19, 20.
1 through 4, 17, 19, and 20. Here's 1 through 4. And now these look a little different than the one I just showed you. That's why I'm going to go over it with you. These are ordered pairs. 0 goes with 5. 3 goes with 2. So this is the ordered pair 0, comma 5. 3, comma 2. 6, comma 9. 8, comma 5. And 9, comma 2. You with me so far?
9,
So it's not a function.
9, comma 4. My bad. Is it a function, yes or no?
No.
No.
Yeah.
Yeah.
I'm hearing some yeses, I'm hearing some nos.
Maybe.
Maybe. Does 0 only go with one thing?
Yes.
Does 3 go with only one?
It is a function, yes.
5 goes with multiple. Is that a problem?
No.
No, it's not a problem because it's a, we can. That's the
Two
birth
different
date.
people.
So this is a function. Yes or no? What are we putting on the line?
Yes.
Yes. Mm-hmm.
Will the answer key be yes or no or function?
It'll be yes or no. Good question. All right, number 2. 0 goes with 6, 1 goes with 8, 4 goes with 4, and 8 goes with 7. Is this a function?
Yes.
Yes.
Yes. There's not even any duplicates on this other side. Before I go too far, I want to make sure I understand. These have 2 sides. What did we say the input was called? What's another word for input? Do you remember on our vocabulary? Domain, that's right. So this would be the domain side. This is just a review.
These are all functions.
This is the domain side. And then is
No,
this,
it's not all of them.
and then what's this, the output side is called the
Range.
range. Okay. Let's go to number 3. Is number 3 a function?
Yes.
Yes.
I've got 2 goes with only one thing, 3 goes with only one thing, 4 goes with only one, and 7 goes with 1, and 9 goes with 1. But this 7 over here goes with 2 different ones. Is that a problem?
Explain why the 7 goes with 2 different ones. I don't.
It's to the 4 and the 6.
7 goes with the 2 and the...
But is that a problem?
Is that a problem? That's
No,
that's a
it's
good
not,
question.
because
That's
that's the output.
That's because that's the output. Very good. So the answer is, yes is a function or not?
Yes.
Yes.
The next one is not.
I heard it's
Yeah,
not.
that one.
All right. I heard a no. What's the number 4? What's the problem? Which one is giving us the issue?
5.
The number 5 has 2 outputs of a 1 and a 7. And so that is not a function. The answer is no.
Oh, this
No,
is
not at all.
also
Not at all. Just write the yes, no, and stuff. Okay. I was just explaining.
No. No.
All right, here we go. We're going to do
Yeah.
number 17. Number 17 is on yours. We're going to skip over to number 17. The question was write the ordered pairs for number 1. I brought number 1 up here so it's close. So this is 0 comma what?
5.
0 comma 5.
Yeah.
So we have, so I'm helping you with the answers here. We're going to do number 17 first, and it says write the ordered pairs for problem 1. Here we go. 0 comma 5. What's another one?
3,
3 comma 2.
How do we write these? Like
6
to the
comma
line or-
9.
You can go down or across, I don't mind. 6 comma 9, good job.
8 comma 5.
Yes.
And 9 comma 4.
Okay. And please verify that he got those correct.
Yeah.
All right, that is number 17. You wrote the ordered pairs that went with problem number 1.
Oh.
Okay? All right.
Yay.
What was the next one I said I was going to do?
19.
19. 19 says I want you to give the domain for number 1.
7.
6, 8, 9.
That's correct. These are all the inputs.
Oh.
These are the domains. Okay. So that a domain is 0, and I'm going to write it like this, 0 comma, 0 comma 3 comma 6 comma 8 comma 9. Okay. That's the domain. That's the input. Number 20 asked for the range of number 5. I put number 5 up there. You can go look on your paper for number 5 if you want, but I brought it up here so we can have it in our visual.
So 1 comma 2 comma 3 comma 8 comma 9.
Very good. The range is the outputs. That's over here.
Oh, I see. I looked at the wrong
Okay.
side. But that's okay.
So
It's
1
fine.
comma 2 comma 3 comma 8
Your mom.
comma 9. Questions about numbers 17, 19, or 20?
Yes, can we do problem 11?
We're going to go there pretty soon. Yes. Okay.
So I was gonna say, it's
Yeah.
really weird looking.
Yeah, we have not gotten there yet.
Skip over this? Really?
We're not skipping. We're not skipping over that.
This looks important.
Same.
It is important. We're not skipping over that.
Yeah,
And now we're
going
going to talk about the coordinate plane. Are you guys ready? We're not skipping over that next section. We're going to go there next.
Coordinate plane, where's this
I don't know that it. Yes, it's in your notes. We're going back to notes. Going back to notes. And I have pictures for you on there, so you can write notes underneath them. So you know where we are, Isaac. Can you show him where pictures at the very top of the
final
page?
page of notes.
Right there. We're going to use those pictures. Okay. I'll be bringing them up in a
Good
second,
stuff,
but just
Brittany.
give us just bear with me here for a minute. This is a little bit of review, I think. This is going to be talking about some graphing. Okay. When we graph on what we call a coordinate plane, we're going to have an x-axis. The numbers that are positive are going to go towards the right, and the numbers that are negative are going to go to the left. You've seen this before. Then we have a y-axis. The positives go up and the negatives go down. No, most of you, I don't think this is anything new. We've also talked about the coordinates. We start at the far right and we go counterclockwise 1, 2, 3, and 4. So far, this is just review and formula madness. All right. We also graph these in ordered pairs. The x and the y is in alphabetical order. X come before y. X is first, y is second. So if I gave you an ordered pair, 2 comma 3 and 2 comma negative 3, I'm going to graph them like this. I'm going to come over to 2, which is there on the x-axis, and I'm going to come up to 3 right there. Questions so far? 2 comma 3 is graphed 2 on the x and 3 on the y, and we kind of just come together to where they are.
So we're just watching you. We're not doing this.
We don't have to. You just watch right now. 2 comma negative 3. What quadrant will that one be in?
4.
The fourth quadrant I heard.
I agree.
2 comma negative 3 is going to be down here. Look at this over here. The 2 comma 3 and the 2 comma 3. Is this a function, yes or no? Because 2 has 2 different outputs, correct? I want you to look at this.
We'll never have a straight line.
I want you to look at this graph. If we're graph this, and I'm not going to. What could I put between these 2 points? What kind of shape could I put between those 2?
A line.
What kind of line? A vertical line. Very, very important. I want you to write at the top of your page right there, I want you to type in, write vertical line test. And I'm going to explain what that is. If you want a vertical line test at the very top of that paper, vertical line test. If you need to put a definition with it, you may. If you think you'll remember it, then don't write it. But this is the vertical line test. If you can put a vertical line on a graph and it touches it in more than one spot, it is not a function because they would have two different y values for a same x. Okay? And we can't have that. We said that wouldn't work for a function. So let's look at these 3 graphs that I'm going to come up here on the screen. I've got this one right here. So what I'm going to do is in my mind, I'm going to bring an invisible vertical line all the way across it. And in this case, that's going to be a real one. But when you do your homework, you're going to take an invisible one. Okay, we want to know, does every x have only one y value? So I'm going to use the vertical line test, and I'm going to bring a vertical line all the way through. Does it ever touch that purple in more than one point?
No.
So that would mean that it was a function. So this would be a function. If this could go all the way across, we would, in the sense of bring our pencil vertically, it would go all the way across, and it would be a function.
Function.
So we could put a yes or
When you
something
mean
like
a
that, okay?
different Point, you mean if you move it across your paper, it'll hit the bottom point.
It's only hitting it once. Over here, it was only hitting it once. As it was moving itself across, every time it only touched that one time.
But what about that straight line right there on the very left?
Let's come back. Let's go. Here we go.
All those points right there. See, it hits all the.
Oh,
points.
I see. It does look like that, doesn't it? This technically is really just going slanted it does look like that. My drawing does. I apologize about that. Let's look at that second one. Is it a function, yes or no?
No.
Because if I do that, I'm coming across, right? I'm coming across, and even where I'm going to stop it right there, it's going to cross at 3 points. It's not a function because that vertical line is hitting that graph in more than one spot. So no in this case. So what about the last one? Is it a function?
Yes.
Yes, because as I bring
So
my...
what would the one in the middle be called? I forgot. I'm sorry.
not be a function because it's hitting...
Is there a
3 times.
name for a not function?
It's
line?
just, if the question would be, is this a function? And your answer would be no. Okay? Number 3, or the last one over here, is yes a function. Only one that was not a function, that one in the middle. You guys with me? Mm-hmm. Okay, so now let's go. Let's go to numbers 9, 10, 11, 12. And we'll do number 9 first. That was on we're going to your homework now. Is number 9 a function, yes or no?
Yes.
Yeah.
I heard a yes. Said yes is a function. Is number 10 a function?
Yes.
I heard yes.
Yeet.
Do we agree?
Yep.
What about number 11?
Yes.
What about number 12?
No.
All right. 12 is the only no we had. These ones should be super, super fast. Function notation. This is the way that we write down that it is a function. Okay? This has an F and an open parentheses and an X and a closed parentheses. We read this. This is how we read it. F of X. We don't read this F times X. We read this F of X. This means that I have a function, and this means that I have variables of X. When I first saw this the very first time, I was so lost. So I want to make sure that I'm not confusing you. This is super. They're not trying to make it complicated. They're trying to make this simple. This means that I have some function, and it's named F. And all the variables on the other side of that equal will be X's. That's all it means. It means that and then if I'm going to evaluate it, if I put a number in there, it means I'm going to just substitute that number in for X. It does not mean I'm multiplying F times something. This does not mean multiply. One of the only times when we put letters next to each other that it doesn't mean multiply. You're going to see this over and over and over, and eventually you're going to sink in, and I'm going to show you an example. I need you to just watch this next little thing. You don't have to. This is not one of the examples in your book or in your assignment sheets. It's just me, okay? So I'm giving you a function, f of x equals 2x minus 3. That's the function. The function name is f. This x next to it says that there's only x's over here. That's all it means. This means that I have a function called f. It's got x's over here. If I asked you to find f of 3, I want you to notice that normally there would be an x right there, but we put a 3. That means that since I put a 3 in for that x, I want to put a 3 in for that x. It just is a shorthand
For every
notation.
x,
For
right.
every x there would be in the equation that you're going to replace with with 3. Mathematicians are those antisocial type. They don't like to talk. They want to write 4 little symbols that say substitute in 3 for x. They don't want to write a big long sentence. They want to write f open parentheses 3 close parentheses and be done, okay? And that means, translation of the new language that you're learning, substitute 3 in for x. So that's all we have to do is we come over here. You've done this many times before. 2 times 3, because I substituted the 3 in for x, minus 3. What is 2 times 3? 6. And 6 minus 3 is
2.
how much?
3.
All right, so this just means shorthand notation for substitute a 3 in wherever you see an X. We're going to do numbers 23 and 25 together. Isaac requested this. I already had you covered on this. Number 23 is here. So it's telling us what f of x is. F of x is 3x minus 2, and it's telling us to find f of negative 1. What does that mean I'm substituting in for the x? Negative 1. So I'm going to go 3 times negative 1 minus 2. We covered this, chapter 1, we covered this already about the substituting in. We just have a new notation on how to tell you to do it. What is 3 times negative 1?
-3.
3.
And then I bring down my minus 2, so negative 3 minus 2, it's catching up.
-5.
Negative 5. Okay.
Then we would circle -5.
That's correct.
And that would be right.
That would be right. All right, now I want you to notice that we don't always name our functions with f. Some of them, this is the function called p. And p says the variable is going to have a's over here. And if you look on the other side, yes, there are a's on the other side of the equation over there. So if I'm finding p of 4, I'm going to substitute 4 in for all the a's. So I'm going to come up here because I have more room. So I'm going to have 4 squared. That's a game you play. Minus 5. 4 squared is how much?
16.
Minus 5. I heard 11. Did everybody get 11? Let's review. Here we go. We were introduced to the definition of a function. For some of you, this might be brand new, this function stuff. We've been reviewing a lot, and some of this might be brand new, but it's like in the recesses, and you need it all pulled back, and you don't remember a lot. The key to that function was for each input, there's exactly one output, and the key was that we read it forwards, but we do not apply it backwards. We used that birthday thing that a person has, 2 people can have the same birthday, but one person can't have 2 different birthdays. So we can go forward on that one, but not backwards. We also identified some mappings. Those were those bubbles with the lines going across. And we also looked at some graphs, and we did the vertical line test. We learned a new notation. This is not f times x. This was f what? F of x, and that just said we had a function named x with variables in it, with letters that were x, and we learned how to evaluate them, okay? The math part of this is really not difficult. It's actually the new concept of understanding what all of they're telling you to do with the new notations. Okay?